Hi everyone, I'm Dongli with Wang, Peng, Laurence, and Polo and Kaitai. We are going to present our work named Distinct Dynamic Searchable Encryption Resist Volume Leakage in Encrypted Database. Our work is focused on the distinct search and resist volume hiding in encrypted systems. So, what is the d-DSE applied in encrypted base? The d-DSE in encrypted base contains three functions called setup, update, and search. The setup is initialize the encrypted base, and the update function will extract the client's input, like records in encrypted base table rows, and the and the keywords is encrypted at the index, and the values are encrypted at the encrypted value. So this will be updated into the encrypted database. And then if you want to retrieve these encrypted values, you can use a keyword query that designates the keyword and generate the search tokens from keyword values. Then the server will get the search token and retrieve the corresponding values, encrypted values from send back to the query's result. So we analyze the patterns in this work mode and find two main patterns. The first pattern is search pattern that names whether two queries are identical. And the next pattern is volume pattern, which is the response length of match records. We can see that if the adversary that just on the query's server knows the pre-knowledge about the query's response length, it can infer the keyword from the query's length. Yes. So currently, the researchers has developed some pattern strategies to conceal the volume patterns, just like add some dummy data via the client's update operation. And then the retrieval response is nearly identical. So this false positive data has ensured the volume is consistent enough. But we also need to aware that the client should estimate the pattern score, and the dummy data is hard to delete from the encrypted database. Alternatively, we've investigated the queries in encrypted database and find alternative queries named distinct keyword query. The distinct keyword query will just retrieve the distinct encrypted values from the encrypted database. So we can see that the adversary if we want to know about the total response length of the distinct keyword query, he should know the keyword or correspondence between keywords and values. So if we want to conceal the volume pattern in distinct queries, we can hide how many response lengths comes from the encrypted base. In other words, the combination between keyword and repetitive values. So that in this, if we can achieve this, we can make safe distinct keyword queries in encrypted base. And another question is, we need to use the distinct keyword queries to feed back the queries in encrypted base. So we summarize our contributions, and now the first is distinct d-DSE scheme that the main differences on the retrieval that we just retrieve distinct keyword values, and we based on the d-DSE and construct the queries in encrypted database, just like update queries and the keyword queries from distinct queries and the join queries from keyword queries. So in distinct DSE, we refine the forward and backward policy in DSE that the two difference is the forward policy should additionally hide the repetitive value information. And the next difference is backward policy should reach type 2 to hide the relation between addition and deletion. Besides, the forward and backward policy just hide the content from the repetitive ones, and we need another security to hide the countermeasure from forward and backward policy. So we define a new security notion called distinct with vulnerability security. The distinct with vulnerability security contains the adversary and the challenge to side. The adversary will send two signatures that includes the keyword space and the relation of one keyword according with all values, and the one keyword according with the distinct values. After the challenger receives the two signatures, he can randomly choose one signature to construct the inquiry base and then gives all leakage to the adversary. After that, the adversary will decide which signature has the challenger choose. So if he cannot determine negligibly to the challenger choose, then they will not have advantage to know which keyword values is in the signatures. After that, we design a framework to enhance the DSE security. The DSE security before we contains three components called distinct classifier, distinct state, and the distinct constraint. The distinct classifier saves how many distinct values in our input, and then the distinct constraint will remove the other repetitive values from the DSE input. And at last, if we want to retrieve the keyword queries, we can restore the number of all values from the distinct constraint and the distinct states. After that, we apply the distinct DSE schemes into the inquiry database. The way we apply application is based on a general architecture like CryptDB or ARCS. The architecture contains four components called the query planner, translation, and the EDB controller and the response program. The query planner will forward the DSE token to the EDB controller, and the d-DSE query model will translate the client's queries into the d-DSE search protocol, and the response program will reply the search protocol operations. In our query constructions, we work through 4 steps. The 2 steps is just apply the d-DSE protocol and the update protocol and search protocol. In step 3, we allocate a local hash map to record the actual repeated values in client's input and retrieve, and after the d-DSE search protocol retrieves the distinct values, will restore the actual values. And step 4, we construct the join queries based on the keyword queries. The queries is we first use a keyword query from all values from as foreign key, and the foreign key will treat it as the next keyword to perform keyword queries on other tables. In our comparison, we compared with pattern strategies used in 3 data sets. And the comparison has 2 access named scamming layer and the query layer. The first layer has a good communication advantages. Yes. And this is the comparison with shell and shell DB that is a prototype of inquiry database. Thanks for listening.